right, today we're looking at notes 6-1, square roots as inverses. So I want to refresh your memory and say, find the inverse of, first, this linear equation. So f of x equals 2x plus 1. So remember, our first step is to rewrite f of x as y. So y equals 2x plus 1. Then you're going to switch x and y. So x equals 2y plus 1. Then you're going to solve for your new y. So in this case, that means minus 1 from each side. And then x minus 1 equals 2y. And then you need to divide by 2 to get y completely by itself. So then to complete it, you're going to have, there's a 1 in front of this, 1/2 x minus 1/2 equals y. And then you're going to decide, remember, are you going to rewrite y as y negative 1, y to the negative 1, or are you going to rewrite y as f to the negative 1 of x? So remember, these have different meanings. You can only use this if and only if the new equation is a function. Okay, so is this new equation a function? Well, it is also a line, it's linear, and it has a slope of 1/2, meaning it goes up 1, right 2, up 1, right 2. So it's going to look something like this. Yes, it's going to be a function. So you can go ahead and say f negative 1 of x equals 1/2 x minus 1. It is a function. Okay, so obviously that was just a refresher. Let's talk about the new stuff. So now, today, what we're going to be learning about is finding the inverse of square roots. So let's start with, square roots as inverses. So let's start with this simple quadratic, okay? So this is the quadratic parent function. Hopefully that comes to your mind and you know what it looks like in your brain if you were to graph it, because we're going to need that in just a minute. So just like before, we're going to follow the same steps. So replace f of x with y. So y equals x squared. Then you're going to switch x and y. So x equals y squared. Then you're going to solve for your new y. So if I want this y all by itself, that means I need to square root both sides. But remember, we've worked with this recently. If I square root both sides, I need to bring in plus or minus. When I square root, I have plus or minus square root of x equals y. So here's where you really need to decide and think, can I rewrite this as this or this? Which notation am I going to use? Well, in order to know, you really need to graph it, at least in your head, if not on paper. So let's go ahead and graph it just to see. So I'm just going to draw a rough sketch here. So of this graph, and remember, I've got two graphs here technically. I've got the positive square root of x and the negative square root of x. So the positive square root of x will look like this. If you remember your original values, it hasn't moved left, right, up, down, anything. So 0, 0, 1, 1, and 1, 2, 3, 4, 1, 2. So there's square root of x, but I've also got negative square root of x. So that means it's been reflected as well. So I've got positive square root of x and negative square root of x. Negative square root of x looks like this. Don't you agree? It's been reflected. Okay, is that graph a function? Well, hopefully no. You'd say right away, no, that doesn't pass the vertical line test. That's not a function. So I know I need to use this notation, y to the negative 1. This is the inverse equation, not an inverse function because it's not a function. Okay, so here's what I want you to think about. Does this make sense, number one, that it looks the way it looks? So let's look. So this is the inverse equation, y negative 1 equals plus or minus square root of x. That's what this graph is. Now let's go ahead and graph the function, f of x equals x squared. Okay, so let's think about how that graph looks. All right, we've talked about this before. You just probably don't remember. So here's the original function. And let's talk about a couple of things. It's been a while since we've talked about. So first of all, inverses. These two graphs are inverses of each other. They have x and y values that are switched. Is that true? On this graph, I've got -2, 4. So on this graph, I should have 4, -2. I do. On this graph, I have -1, 1. So on this graph, I should have 1, -1. So let's just check them all. 0, 0. Obviously, if you switch it, it stays the same. The point 1, 1, if you switch it, it stays the same. But this point here, 2, 4. It should become 4, 2 over here. 1, 2, 3, 4, 2. Yes, they have x and y values that have been switched, coordinates that have been switched. Okay? Another thing I want you to remember, it's been a long time since we've talked about. This graph is a function. Yes, it is. It passes the vertical line test. But is this graph 1 to 1? Remember that word 1 to 1? 1 to 1 means it passes the horizontal line test. Does this graph pass the horizontal line test? No, it sure does not. Which means if this graph is not 1 to 1, its inverse will not be a function. Okay, and we see that. Its inverse is not a function. So what we really talk about, and I really hope you're getting this, is how can, so my next kind of side note question is, how can I restrict the domain of the original function so that the inverse is a function? How could I do that? So if I restricted the domain of this graph, say, to only be the right half of the graph, if I restricted it to say that x such that x is everything greater than or equal to 0, if I said, let's forget about this left half and only think about the right half, if I restricted that, would that create an inverse that is a function? Well, yeah, because the only points I would switch would be these two, so that would actually produce only the top half of this graph. So when I take the square root here and I bring in the plus or minus square root of x, what would happen is we'd say, well, whoa, you restricted the domain to be x is everything greater than or equal to 0. So that means you wouldn't be able to bring in the plus or minus, you'd only bring in the plus. So yes, you can restrict this graph to make the inverse a function. Could I not also have said x such that x is less than or equal to 0? Would have that done the same thing if I only looked at the left half? Well, definitely. Then that means I'd only have the bottom half of this graph here. Okay, so when you work with taking the inverse of a quadratic, likely you're going to have to restrict the domain in order to create a inverse that is also a function. So let's talk about more. I'm sure you have a bunch of questions still. So if I said find the inverse of something a little bit different from the last, x squared plus 3. Okay, same steps. You're going to y equals x squared plus 3. Okay, then you're going to switch x and y. So x equals y squared plus 3. Solve for your new y. So minus 3 minus 3. X minus 3 equals y squared. Then you can square root both sides. Okay, so remember when you square root both sides, you got to bring in the plus or minus. So plus or minus square root of x minus 3 equals y. Is that going to be a function? Hopefully right away you're saying, no, that's not going to be a function because you've got the positive and the negative. One's going to be facing up, one's going to be facing down. That's not going to be a function, but let's talk about it. So the original graph here, oh, you know what, let's bring it on down a little bit. The original graph that we had was f of x equals x squared plus 3. So that means we moved up 3, and then from there the points were the same. So we've got something like this here. Okay, so that was the original. And then the inverse equation was this here. Okay, so this shifted right 3, so 1, 2, 3, and 1, 2, 3, 4. So here's my points. So that's the positive version, and then we also have the negative version. Okay, so there's the inverse equation, so that's that graph there. So is that a function? No way, it's not. Anytime you have the plus or minus with the square root, because one's on the top, one's on the bottom, you're not going to have a function. So then I would ask the same question. How can you restrict the domain? So restrict the domain on the original to create an inverse that is a function. So again, same type of thing. You can either look at the right half or the left half. Commonly, people are going to take the right half because that's the positive version. So you would say restricting the domain would be x such that x is greater than or equal to 0 would create only the top half here. So then that would mean that the inverse is a function. Okay, let's do one more. We have a brief minute for one more. So let's look at f of x equals x minus 3 squared plus 1. So rewrite f of x as y. Okay, switch x and y. X equals y minus 3 squared plus 1. Solve for your new y. So minus 1 minus 1. You get x minus 1 equals y minus 3 all squared. Square root each side. So you have plus or minus square root of x minus 1 equals y minus 3. So you're going to have to add 3. So you're going to have plus or minus square root of x minus 1. That's going to kind of go to the tail end, but it won't be in the square root, equals y. Again, if you've got that plus or minus, then you're not going to have a function, so you would write it like that. And hopefully you know on this one, since it has shifted a little bit differently, so we've got a graph that's been shifted to the right 1, 2, 3, and up 1. And then from there, it's got the original points because it hasn't been stretched or reflected. It's going to look like this. So if I ask you to restrict this graph in order to create a function, inverse that's a function, restrict domain to create an inverse that's a function, in this case you're going to say x such that x is everything greater than or equal to 3. So it's not quite the same, it's a little bit different from the others because of the way it's been shifted. Or again, you could have said x such that x is less than or equal to 3. It's just common practice that you use the right side.